Today is January 2nd, 2013. My name is Anthony Karam. What we have here is a design or chart of the neutral zone of Wesley Gary's statement he put out in the Harper's Monthly magazine in 1870 regarding his identification of a neutral zone, and also of a patent that he acquired. He also identified this as that location of the neutral zone. So what I did is I identified it, and now I'm verifying it here today. That yes, it exists and it can be found. And I'll explain to you how you find it. If you look at the, and I'd like to know if anybody else is able to find it just by my descriptive analysis of this video. So let me try to explain it simply. You look at the very upper right, you'll see a cross, and the cross is going to be the coordinates of a permanent magnet compass. Now, if you look at the bottom vertical is all that matters here. The bottom vertical will be the south to begin with, and the upper vertical will be the north of the cross. That's all important here. That's the only thing that's important here right now. Forget about the east-west, because we're not concerned with that. We're just concerned with the magnet compass. North, south, vertical. Now, to the right of the compass and just below it you'll see two dashed lines, north-south on the upper part, the dashed line on the left, and the dashed line on the left of the south-north. Well, let's just concern ourselves with the dashed line of the south-north and go completely across the page or the video or the screen to your left and intersect the two dashed lines all the way to the left of the screen and draw an imaginary horizontal line, and that's where your pole piece is going to be floating in midair, stationary, and the center of the pole pieces will be the dashed line on the left, and the center of the pole pieces will be the dashed line on the right of the south-north coordinate of the horizontal south-north coordinate. Okay? Now that's just a descriptive analysis of the location of the horizontal floating pole piece, metal pole piece. Now let's go down below, all the way down to where you'll see two more horizontal dashed lines, one adjacent and to the left of the north, and one adjacent and to the right of the south field, down in the bottom above the ruler. Now, the dashed line at the 3/4 inch mark on the ruler, above the 3/4 inch mark of the ruler, will be where the permanent magnet, horseshoe magnet, of the South Pole will be. The top of that permanent magnet will be that horizontal line in the center of it, of the South Pole. Now, as the horseshoe magnet goes down into beyond your screen, to the base of your screen there, and beyond, it loops around and goes all the way back up to the other side of the screen, to the right of the screen now, where the other, where the North Pole will be. So that dashed line next to the North Pole at the, let's see what, that'll be at the 3 3/4 inch mark of the ruler. So that's the North Pole, and the 3/4 inch line, horizontal line, will be the South Pole. I'll go back up to the pole piece. Now we're going to move that pole piece, the metal pole piece, that is above all this, just below the compass there, that runs horizontally, that I described earlier. And we're going to raise it 3/16 of an inch. And when we raise it 3/16 of an inch to where from the south-north coordinate there on the center of the pole piece where it was originally, and now it's going to be raised up to the north-south designation there, okay? 3/16 of an up, 3/16 of an inch up. At that point, the compass will turn 180 degrees, and the metal pole piece flux will change, and now the north pole of the compass will be facing the pole piece. The north pole of the compass will be at the bottom of the vertical line, and the south pole of the compass will be at the top of the vertical line. Now, we're going to move the pole piece down again 3/16 of an inch at the south-north, their horizontal designation. 3/16 of an inch downward, and when we do that, that compass will switch back 180 degrees, and the vertical line in the center of the compass there, the bottom of the vertical line will now become the south pole, and the top of the vertical line will become the north pole. It will switch. The compass will switch, because the metal pole piece field will change just by that slight movement. Now, I'm going to do it one more time. If we move the metal pole piece 3/16 of an inch up at that quadrant there to where it is, where the north-south horizontal line there is, the compass will switch where the bottom of the center of the vertical line of the compass will be north, and the top of the center of the vertical line of the compass will be south. If we move the metal pole piece 3/16 of an inch down again, back to where it was originally located at the lower dashed line there of the south-north horizontal designation, when we move the compass or the pole piece down at that point, just 3/16 of an inch, the compass changes back to where it flips 180 degrees, and the south pole now will be at the bottom of the vertical line of the compass marked there, and the north pole will be at the top of the vertical line, which means the pole piece fields have changed again. And that's what's happening. The pole piece at the beginning, at the lower dashed line there, will be north. And if you raise it up again 3/16 of an inch, it will switch to south. And that's exactly what Wesley Gary said would happen. The pole piece is untouching any magnetic field, physically touching any magnetic field magnet whatsoever, and it's so easy to change that field, it's unbelievable. There's hardly no force that you have to overcome to move that pole piece, and yet the field changes 180 degrees. It changes from north, to south, then from south back to north with only 3/16 of an inch movement. So that's what I'm putting out here today, and that's the end of my tape. And I'll be curious to find out if I get a response at all on this.